Hi, friends. It's Mr. Rogers here, and I hope that you guys have had a wonderful day so far. And we're going to go over the Punnett squares that we did over break. There's 10 of them. First five are the ones I was really kind of like making sure that we knew how to do. The last five, they were kind of just to see where you're at different levels. And, if you did them well, that's awesome. If you didn't do well, don't worry. We're going to go back through. So number one, white coloring in guinea pigs is recessive. What will the offspring be from a cross between a white guinea pig and a heterozygous black guinea pig? So taking a look here, these are just simple monohybrid crosses. So it's the old traditional rules of dominant wins over recessive. So you have dominant traits, and if you have one of the dominant alleles, it's going to be the dominant, whatever it is, whatever the trait is. So in this case, for number one, we have a heterozygous black guinea pig. That's the key to this sentence. Heterozygous means it has one big and one small. So a heterozygous black guinea pig would be, we'll use letter A, big A, little a. And because it's black and it's heterozygous, meaning the big A has to mean it's black. Little a means it's white. So this white guinea pig over here is homozygous recessive. Again, how I figured that out is heterozygous means it has one dominant, one recessive, and it's black. And we know in heterozygous a dominant wins, so big A must refer to being a black guinea pig. So big A, cross of the little a, what you should find out is 50% of their offspring is white and 50% of their offspring is black. Free earlobes are dominant over attached earlobes. What will the F1 offspring be from a cross between heterozygous free earlobe parents? So we're going to two heterozygous free earlobes, so it's dominant, so it's big A, cross with big A, little a. We should get one big A, one little a, two big A, little a's. That's the genotype breakdown, so 25%, 50%, 25%. And then the phenotypical breakdown, that's what they actually look like. 75% are free earlobed children because you only need one dominant trait. 25% is going to be little a, and they're going to have attached earlobes. The ability to taste phenyl, I'm not even going to try, phenothiocarbamide, PTC. We actually have these strips in the classroom. We could do this during a normal year. Is dependent upon a dominant gene T. The recessive allele little t is associated with the inability to taste the substance. What are the possible genotypes for tasters for non-tasters? So to not taste it, you have to be little t, little t. For tasters, you're big T, little t, or big T, big T. Two parents, both tasters, have a non-taster offspring. What are the genotypes of the parents? Well, they're going to have to be big T, little t because they had a child that was little t, little t. So each one of the parents had to give a little t to their offspring. Two parents, one taster and the other a non-taster, have a taster offspring. What is the genotype of the offspring? Well, one is going to be little t because they're the non-taster. The other guy could honestly be either one. They could be big T, or they can be big T, little t. Because even though the big T, little t with the non-taster could have a non-taster baby, in this case it has a taster baby, there's still a high chance of it. So it could be either one. It's not really that big a deal. This one, some of you guys could have just went with big T, and that would have been fine too. In Drosophila, fruit flies, the curly wings are recessive to the normal wings for straight. It's recessive to its normal allele for straight wings. So straight wings are dominant, curly wings are recessive. A homozygous curly wing male is made of a homozygous straight wing female. What would the genotype and phenotype of F1? So here we have, we'll use little a's again. Little a, made with a big A, big A. So everybody's going to be big A, little a. in the genotype and phenotype, they're all going to have straight wings because they all have a big A. In the alien race, whatever, hairy tongue is recessive trait to the normal hairless tongue. The male is heterozygous normal tongue, has children with a homozygous normal tongue female. So the male is big A, little a. The female is big A, big A. She is homozygous, not heterozygous. What would the genotypes and phenotypes of the offspring? What percentage would be hairy tongue? What percentage would be normal tongue? So it should be 0% hairy tongue because we have the second you have somebody that's homozygous dominant, they're not going to have any recessive children that have both recessive traits because the one parent can't give a recessive trait. So it should be 0% here. It should be 50% big A, 50% big A, little a. The phenotype should be 100% hairless tongue, or the normal tongue. Cool. Those are the first 5. I'll make another video in a little bit about the next set, but those are the first 5 that I'm truly going to look at and everybody's and grade you on. The next 5 are kind of just give me an idea of how much do you actually remember. So if you have any questions, let me know. We're going to kind of start with Punnett scores pretty quick here. I just kind of wanted to see where everyone was. So thank you for watching. Talk to you guys soon.